Hi, this is Lance, and this is my project for data analysis in the fall of 2017. My project is called Bot or Not, Modeling Bot Behavior on Twitter. Here are the project objectives. I wanted to analyze the behavioral aspects of the retweeters of Donald Trump tweets. I wanted to search for correlations between tweet features. I wanted to build and test a model that classifies users as likely bots. Then I wanted to deploy the model on in and out of domain tweeters, other tweeters users' accounts for comparison. But each one of these objectives has certain considerations. I would like to go through them now. In analyzing the behavioral aspects of retweeters of Donald Trump tweets, it's important to remember that user data is unavailable for Twitter users. So I had to use retweeters of Donald Trump tweets as a proxy. Next, because I was not using semantic clues for examining the tweet, I was just using behavioral clues, it limited my analysis options. And finally, Twitter data is noisy. There are non-ASCII characters that have to be dealt with, and a whole array of things that have to be dealt with when you're trying to conform the Twitter data to a norm. Then there's the search for correlations between tweet features. Consideration that correlations might be found, but are they meaningful for identifying bots? Good question. And building and testing a model that classifies users as likely bots. Well, it's impossible for me to know if a certain user is actually a bot. And finally, to use the model on in and out of domain Twitter users' accounts for comparison, it has to be asked, does bot behavior from one domain resemble bot behavior from other domains? That is using a political bot detector model valid in other domains? So here you see my KNIME workflow for gathering Twitter data, and I gathered 40,000 tweets. And you see here's some of the Trump data that I gathered. And one of the most important parts of this data was the user creation date, which allowed me to determine the number of days that a given Twitter user had been active between the creation date and the date on which I gathered the tweets. So at that point, I started my data transformation. First, I created meaningful variables from the raw data, such as days active, as I just mentioned. Then I normalized that data because of the wide array of length of times active. So I created tweets per day, favorites per day, and such as that. And finally, I had to create a target variable of bot or not bot, and I based that on cluster analysis to see how what the data spoke about where the different clusters lived. And here's my model building procedure. First I added the Excel reader to read in the Trump data, Twitter data, and then I used a color manager, of course. And then I partitioned the data for 80% training data and 20% test data. Added a decision tree learner and a decision tree predictor. And then the rest of it, you can see I used a score, and then after my model was finished, I wrote the model with a PMML writer. And here's the one of the decision trees that I got and you can see that user statuses and days active are both absolute variables that are extremely significant in this analysis. And so when I analyzed the data on 41,528 tweets, I found that 7,434 of them were determined to be bots for a number of 17.9% bots. Now I have concerns about my classifier. First, that I didn't have an authoritative annotated data set that was available to train the model on what was or was not a bot. Also, I had to recognize that bots are becoming increasingly sophisticated and hard to detect. Also, tweets per day was the overwhelmingly most significant variable, with a far distant of favorites per day as second most significant variables. There were other variables such as user language that could potentially have been very meaningful, but they were so underrepresented in the data to have hardly been useful in any way. So at this point, I gathered 5 additional Twitter users' data, and I used the same procedure as the Trump data set. Because it was so difficult to gather data in large quantities, I had to bootstrap the samples for each of these comparative domains to 15,000 tweets, and then I deployed the model as before on each data set. Here are my comparison domains: Bernie Sanders, a liberal politician; Hillary Clinton, the 2016 Democrat presidential candidate; Sean Hannity, a conservative TV personality; LeBron James, an NBA basketball superstar; and Halsey, who is a current popular singer that my 13-year-old daughter is obsessed with. As you see, Sanders had 11.3% bots, while Hillary Clinton had 19.9% bots, very close to the same number as Donald Trump. Sean Hannity, however, had 30.3% bots, most of anybody I checked. LeBron James, the basketball player, had only 3.7% bots. And Halsey, our favorite pop singer, had 22.6% bots. I hope you've enjoyed this video, and I thank you very much.